I just want to start by correcting that so that nobody gets confused. So here is a mistake that I just want to go through. So it says, Jonathan deposits 3,000 into a bank account that offers an interest rate of 15% per annum compounded monthly. How much will Jonathan withdraw after 6 years? So step one is you need to identify the correct formula, which is the compound growth formula. And you have to identify that the p-value was 3,000, that the I-value was 0.15 divided by 12 because it's compounded monthly. Okay. And then for n is not going to be 6. What is n going to be in this particular question? What do we think it's going to be? Yeah, so it's going to be 6 times 12, which is 72. And so the answer to this question should be, so the 15% interest rate is chopped up into by 12, and then this should be to the power of 72. And so 3,000 times 12 to the power of 72, and we should be getting 7,337.76. And so if you were a bit confused about that question, well, it's understandable because the answer should have been that. So give me a thumbs up if you follow that. Give me a thumbs down if you're unsure about something I did there. Okay, fantastic. All right, so then let's get on to today's main topic, which is depreciation. Actually, no, before we even do that, I just want to show you where finance, growth, and decay sits in the overall curriculum. So if you look at your maths in grade 11, there's paper 1 and paper 2. Finance is in paper number 1. And it's generally worth 15 out of 150, or about 10% of paper 1 is going to be based on finance. And if you look at the formulas that we kind of need to know about to help us, so far we've covered simple interest and we've covered compound interest. And sometimes I shorten them to SI and CI. We've also covered something called nominal and effective interest rates, although I don't normally write the formula out like that. What I did in the last lesson was I wrote it out like this. It's the same thing, like that, where the effective interest rate is over here and the nominal interest rate is over here. So those are the 3 formulas you should be familiar with after the first 2 lessons. Give me a thumbs up if they do look familiar. Give me a thumbs down if they look unfamiliar. Okay. So if that's what we've done before today, what are we going to do today? And we're going to look at something called simple depreciation. However, some textbooks don't call this simple depreciation. They call it straight line depreciation. So if you see the word straight line depreciation, you have to know it goes with the simple interest depreciation, or the one where the n is not flying in the sky. Then we're also going to look at what's called compound depreciation, or some textbooks call this reducing balance depreciation, reducing balance depreciation, or it can be simplified to RBD, reducing balance depreciation. And what you'll notice with compound depreciation or reducing balance depreciation is it's got the n, which is a power. Now, the only difference between the yellow ones and the blue ones is that the blue ones are about losing value or depreciating, whereas the yellow ones are about increasing in value using interest. So that's the main distinction that you need to make. Give me a thumbs up if you feel like you understand the small difference between the yellow and the blue. Give me a thumbs down if you feel like you're not clear as to what the difference is between the yellow and the blue formulas. And again, if you don't get it, that's completely fine. Just make sure you make a comment in the chat or raise your hand so I can respond to you. Okay, well then I think we need to get going with the question. So here is your very first question for today. Let me get both of them in view actually so that you can see both. So there's the one question and there is the other question. Okay, so in each of these formulas, in the very first one, it says a car is worth 120,000 and it depreciates at a rate of 12% simple interest per annum. How much will the car be worth after 5 years? And the formula that they've given us, although I can write it above here, the one that you should be using will be that. We'll call this question 1. Then for question 2, it's the same question again, except the method of depreciation is now 12% per annum on reducing balance method. And so the formula you need to use will be that. Can you find me the answers to number 1 and 2? If you get stuck, please raise a question, but otherwise I'm going to let you try and get those answers by yourself. Think about, in this case, the P value would be the big value that you start with, and the A value would be the lesser value, the value that is smaller because it's lost value for later. So in the first one, we should be getting a value like from that calculation, and we end up with 48,000. So that's how much the car is worth after 5 years using simple interest depreciation. Now, what is the car worth if we use the reducing balance or the compound depreciation method? That's the next one I want to know about. I'm probably going to have to use my calculator here. Well, I get that it is now worth 63,327.83. Now, what's interesting is that if we look at how much the car is worth, we talk about how much the car is worth. It's another accounting term. We say the book value of the car in the second method is 63,327. And then in the first method, the book value, or how much it's worth in your accounting books, is in the first one is 48,000. Now, which one has the higher book value? Which one is worth more in your books? Option 1 or option 2? Yeah, option 2 is worth more. Now, what that means is that because option 2 is worth more in your books, there must have actually been less depreciation because, so in this case, there must have been less depreciation because it's worth more. Whereas here, there must have been more depreciation. So what I was saying was, in this question, in both methods, we start out with 120,000 as the value of the car. Now, if we use simple depreciation, the car ends up being worth 48,000, which is the book value. That's how much it's worth. If I use reducing balance or compound depreciation, the book value ends up being 63,327. Now, the book value is how much it's worth, but if you want to know how much value has been lost, we call that depreciation. And so what I was wanting students to do here is to say, well, it used to be worth 120,000 and it's now worth 48,000. So how much has been lost? Well, it's just the difference. So we should get 120,000 minus 48. So there's been 72,000 rands depreciation in the first question. Now, that's why the book value is so much lower. Now, how much depreciation has there been in the second case? Is my next part of the question. If I can move this thing that's stuck, there we go. So in the second case, we would do the same idea, except that we would have to take away the different book values. So depreciation here is going to be whatever it was originally, 120,000 minus 63. Let me just zoom in. Minus 63,327.83. And so 120,000 minus 63,327.83. And my book value, sorry, my depreciation value here, the amount of value that's been lost is 56,672.17. And what you notice is that because there's been less depreciation in the second one, that's why the value of the car, the book value, is higher. Whereas in the first option, there was a lot of depreciation, 72,000. That's why the book value is worth less. Now, I'm just making sure that you understand the words that come up in the section, because a lot of it initially is, if you don't do accounting, book value, depreciation rate, it can sound a bit like they all sound the same. So give me a thumbs up if you understand the difference between the original value, okay, P, the book value, which is the A, or how much it's worth, and then the amount of depreciation. Okay. Yeah. Okay. So then let us then go on to do another question that is along the same lines. So in this scenario, we have something which is losing value, or it's depreciating. And the thing that is depreciating is equipment. And it's a piece of machinery, let's say in a factory, and it's worth 10,000 when it was bought. And then it ends up being worth 5,000 in 4 years' time. Now, then it asks, what is the rate of depreciation? It's almost like, what is the interest rate? What is the rate at which it's losing value? Correct to 2 decimal places if, and the first one is going to be straight line method or simple depreciation. So we have to use this formula. And the second one is going to be the reducing balance or the compound depreciation process. And then you are going to need to use that formula. So I'm going to give you some time to try and work out what A and B is, because I think you probably can see how this is similar to something you've done before. But if you're feeling lost, then I really encourage you to ask a question in the chat, or raise your hand and we can just talk about it. Okay, so you're doing A and B. Find me the rate of depreciation, or find me the I value in both of these situations. Good question, Owami. Owami's asking in the first one, the 10,000 would be the p-value. So 10,000 would be the p-value, and the a value is the final amount, or what you end up with. So that would be 5,000, and the n would be 4. Perfect, Lorato, yes. And the same thing is going to be true here. The initial value is p. Because you're losing value, the final value is lower than the p-value, and then the n is going to be 4. But you still need to work out what the depreciation rate, or the I, is in this calculation. Okay, so for A, you should be getting 12.5% per annum depreciation. That's how much value you're using. You're losing 12.5% of the initial cost price of the machinery. However, that's the straight line depreciation. What about the reducing balance? Oh, let's hit mutual. There we go. Perfect. Okay. Let's see what we do for this next one. So we know this is 5,000. This is 10,000. 1 minus I, and this is going to be 4. But now we divide both sides by 10,000, and we end up with a half is 1 minus I to the power of 4. And the trick is to get rid of the power of 4 is we have to take the fourth root, in which case we get 1 minus I on this side, and we get some rather probably random number here. So 4, sorry, the fourth root of a half, and that's quite a, I would just recommend keeping that in your calculator's memory. And then I, if you bring it across, is going to be 1 minus 0.84089 and so on. And what I get in my calculator is 0.159103 so on, which as a percentage is 15.91%. So, and that's going to be per year or per annum depreciation. So how did I get the answer to A? Yeah, absolutely, Lorato, I'd be happy to. So first of all, you have to make sure that you understand why the p-value is 10,000 and the final value, the A, is 5,000, because that's still a bit confusing because we're losing value now. We're not growing, we're getting smaller. Then I moved the 10,000 to the other side. So I was dividing both sides by 10,000, and 5,000 over 10,000 is the same as a half. On this side, I just left, because the 10,000 had disappeared, you've just got 1 minus I times 4, or 1 minus 4i. And then I moved the minus 4i from the one side to the other, it became positive, and I moved the pink half to this side and it became negative. And then if you think about 1 minus a half, you're just going to get a half. And then you get divide by 4 on both sides, and that's how you get 0.125 or 12.5%. Does that help, Lorato? Did you follow my logic there?
Hi, sir.
Pleasure. Okay. Yes, yeah, there's another question. Who am I speaking to?
So you're speaking to Emmanuel.
Hi, Emmanuel. How can I help?
Sir, I wanted to ask, so when we're doing calculations to find the interest,
Yes.
how do we know when to convert it to a percentage and when to leave it as is, like in its decimal form?
Okay, you're right. So it actually said in this question, the honest truth is you go with whatever is said in the question. And here it says correct 2 decimal places. So did you need to do this bit here? No. And did I need to do this? I did it out of habit, mainly. But if you look at what the question, it says correct 2 decimal places. You could say, you could say that this is 2 decimal places here. Oh, you know what? It depends on, the question has to be clear. This is actually vague because I thought now 2 decimal places, but then you can actually round off the percentage to 2 decimal places as well. You can interpret it like that. So the honest truth is both of these are correct, unless the teacher is specific in saying like something and you haven't done it, you should just get full marks regardless. The convention is to leave it in percentage. That's just because that's normally in the business world how it's done. Okay.
All right, sir. Thank you, sir.
Cool. Okay, everyone, let's get on our feet because we've done half an hour of quality. And so we need to take care of make sure our bodies can help us in the second half. So I want you to turn on your cameras if you're able to do so. And I want you to start by just shake out your arms a little bit. Make sure some blood flow is going around. Shake out the legs. Oh, it feels so nice to be standing up. And then let's do some turning around. A little bit at first, and then as we get more comfortable, we can extend ourselves. Let's do some shoulder rolling. So let's go back and go forward. Okay, and then let's do some small circles with our arms going into big circles. And then let's change direction into small circles. Okay, then let's do some tricep stretching. That's like this. There we go. And then let's shake out the arms again. Okay, so I hope you've loosened up a little bit. Let's do some heart rate stuff. So let's do some jumping jacks, and we're going to do 20 in 3, 2, 1. Let's go. 2, 3, 4, 6, 7. Ooh. Oh, sure, that felt like a proper workout. And let's see if anyone can solve today's Maths 24 puzzles. So here are your Math 24 questions. Can you make 24 using any of these cards? And I will watch as you'll take a moment to let your heart rate recover. And also you can think of, can you solve these puzzles? What do we think? What do we think? The red one, I kind of think I have. Anyone else got it? So yeah, the first one is not too bad. It's just the 8 minus 7 gives you the 1. And then you can just go, is that? Yeah. This is a 9 because the line is at the bottom. So Karabo has said 8 times 3. Yeah, that's correct. What about the blue and the yellow ones? Anyone do those? Okay, I'm going to give you, wait, I got the yellow, but I forgot what I did. No one's got the blue one either yet. The 9 and the 1. So Letabo has said 9 times 2 plus 4 times 1. Let's see. 9 times 2 is 18 plus, that would give you 22. So that's close, Letabo, but not quite. So I like the way you were thinking about things there, but Andile. So Andile says 9 plus 1 is 10. And then 10 times 2 is 20. And then plus 4 is 24. Yes, that is correct. So 9 plus 1 to get 10 is the really important bit. And then you go from there. And then Owami has said 8 plus 5 is 13. 13 times 2 is 26. Minus 2 would give you 24. Yeah. Well, there we go. We smashed all 3 of them. Yeah, it's a really good logic game, and it's a lovely way to just let your brain relax for a little bit between halves of the lessons. Okay, well, let's get back to the second half of our lesson. I hope you had a good break and your body feels like, whoa, it's been a while since I've been learning. Let's start with this old exam question. And I just want you to do the one that's going to be in yellow. So Melissa has just bought her first car. She paid 145,000 for it. The car's value depreciates on a straight line method at a rate of 17% per annum. Calculate the value of Melissa's car 5 years after she bought it. See if you can solve that one for me. So what do we get? What do we get? And once it was worth 145,000, but then after 5 years worth of depreciation, it was then worth 21,750. So it's lost a lot of value. Bonus question, or a little bit extra, how much depreciation has occurred on this car over 5 years? So you know how much it's worth after 5 years, but how much value has it lost? How much depreciation has there been on this car? So it was once worth 145,000 and it's now only worth 21,750. So what is the difference between those two? So it's lost 123,250 in terms of, that's how much value it's lost. It's depreciated by that much. Okay, now, since you guys are doing so well at depreciation today, I'm going to mix in another question from the previous lesson, just to see, how much are you retaining? So let's do the next one. It says an investment. Now, notice it's not depreciation we're dealing with. We're dealing with an investment earns an interest at a rate of 8% per annum, compounded quarterly. The question then is, at what rate is interest earned each quarter of the year? And it's worth 1 mark. So what do you think the answer was going to be for that one? So it's 8% per annum compounded quarterly. Well, how much interest is there going to be per quarter? If your annual rate is 8% per annum, what do you think the pink one's answer is going to be? I think everyone's a bit unsure, aren't they? It's going to be 2%, yes, because it's 8% per year, but you want to know per quarter. So every quarter, it's just going to be 2%. Yeah. Okay, now, it then says, calculate the effective annual interest rate on this investment. So calculate the effective annual interest rate. Now, what I did was I gave you this formula, which I think it's a good idea to memorize, which is that one over there. And so I want you to work out what is the effective interest rate for this particular thing. There is actually another way you can do it, but I'll show you that both of them will work out. But I think this is the quickest. 1 plus 0.08 over 4 to the power of 4 minus 1. We have so 0.08243216, and in percentage, it's going to be 8.24% per annum effective interest rate. Okay, so it's nice to see that the only type of question that we still need to look at, and this is going to be the last 2 lessons that we cover this, is timelines. And in fact, we've even kind of, okay, yeah, we'll come back to that later in a later lesson, but you could actually even do that one already, but I'm not going to do it tonight because I think that would rather stick mainly to depreciation. Okay, here's another depreciation question. So this one says, a company bought machinery costing 80,000 Rand. You are now using the reducing balance method. The machinery has a book value of 20,000 after 5 years. I want to know, calculate the rate of depreciation. So see if you can do that. So first of all, you need to ask yourself, have you got the correct formula? And you should have that formula, hopefully. What do we think? The rate of depreciation. So your P value is 80,000, your A value is 20,000. What is your N? Your N is 5. So I'm going to do that same trick that I did before. And then I have to take the fifth root of this. And on this side, I'm going to get 1 minus I. And on the other side, I'm going to get something messy, I guess. Okay, so we get that. And then we're going to get, this is going to be quite a long 0.7578. I would just store it there. And then if you bring the I across and bring this to the other side, this should be 0.24214117. That carries on. And for our purposes, the depreciation can be 24.21% per annum using the reducing balance method. Okay. Give me a thumbs up if that's fairly clear. Give me a, I think some of you might need a bit more time. Oh, actually, it's not too bad. Cool. Awesome. Okay, well, let's do the same effective interest rate calculation question again. I want you to do calculate the effective interest rate if the interest is compounded at 5% per annum, compounded quarterly. It's a very common exam question, like you can see. So I want to make sure when you see that question, your face lights up. And notice this is not a depreciation question. It's from the previous lesson. And see if you can remember that formula that I gave you. Each time you write it out, it gets a bit easier to remember. So we should be getting which is going to be 5.09% per annum effective rate. And so what you notice is the effective rate, I know this is just a revision from the last lesson, but it's always good to have a bit of revision. The nominal rate is always going to be lower than the effective rate. And the reason it's going to be lower than the effective rate is that the effective rate takes into account the compounding periods of a quarter. And so what this does, this effective rate, is effectively summarizes how the smaller periods affect how much interest you get. If you want more detail on that, I would look at the previous video. I did a lot on this in the previous one, but it's good to know how to use this formula. And in theory, they could also give you the effective rate, and you have to then work backwards to get the nominal rate. So I'll make sure I throw in a question like that later in the 6 lessons. But just to make sure that, you know, if they gave you the effective rate, then all you would need to do is you would need to get this thing by itself, and you would just use the same skills that you did before. You'd move the -1 across and so on. Okay, let's do another question. So I think we are going to, it says here, determine the principal amount, initial amount. A car has a current value. So this is not the initial value. This is the current value. If the value depreciated at 13% per annum compounded quarterly, calculate the initial value of the car 10 years ago based on the reducing balance method. Now, everyone, what's going to happen here is instead of being depreciating using a yearly interest rate, we're now starting to change this to depreciating on a monthly basis. So I want you to think, we're probably going to finish with this question tonight, and then in the next lesson, we'll go into more detail about these ones. But think about what's different. You are trying to find the initial amount. They've given you the book value or the A value. And when you deal with the depreciation, you're also going to have to deal with time periods that are appropriate for the calculation. So I'm going to let you start on this, and then as I get questions, I'm going to help you out. Okay. I'll let you think about that first. So if you think about the interest rate or the depreciation rate, it's not going to be 0.13 in this case because it's compounded quarterly. It's actually going to be 0.13 divided by 4. So what is the number of time periods I need to depreciate for now? What is my n going to be? It's not going to be 10. Okay, it's going to be 10 times 4 because we're dealing with quarters. Now, because we're dealing with reducing balance method, the formula you should be using should be that one. And you want to find me what is that initial P value if the current value or the book value is 250,000. It's quite a sneaky question, hey? It's a bit trickier. So we could start with 250,000 equals P. And then I don't know what I is, but I do know this should be 40. I do know what I is. I lie. I tell a lie. It is, in fact, 0.13 divided by 4. That's the whole point. And then this over here should be 40. Well, let's put it in red so it's nicely color-coded. So in order to get P by itself, I have to bring this whole chunk to the other side. And so I'm going to go 250,000 divided by 1 minus that over 4 to the power of 40. And that's me just using like kind of laws of algebra. And so I need to put this in my calculator, but hopefully you can help me with confirming that what I get is correct. 250,000 on the top of the fraction, on the bottom another, and then open the bracket. 1 minus then another fraction, 0.13 over 4, close bracket to the power of 40. And what do we get? I am getting as the initial value, and it said round off to the nearest rand. And in financial math, so the initial value is 937,348.44. Now, in financial maths, we generally, the nearest value here would be 937,348 because you would round down, although often in financial maths we round up, but in this case it's actually ambiguous as to which one you would use. So as long as you round about that, I'm happy. 348.44. Yeah. Okay. Any questions or comments about that one? So in the next lesson, what we're going to do is we're going to focus a bit more on if we're depreciating something, and the depreciation periods tonight have mainly been one year. Lorato, the reason it's 40 for N is we have 10 years, but the depreciation is being worked out per quarter. So if you look at the question, it says if the value depreciated at 13% per annum compounded quarterly, the depreciation is happening every quarter, and there are 40 quarters in 10 years. And so that's why N must be 40. So in the next lesson, what we'll see is we'll learn how to depreciate using, like here they did quarters. We could depreciate every month. We could depreciate twice a year. And you'll notice that there's a lot of similarities to the compound interest lesson that we did the other day. But that will be Wednesday's lesson.